Okay, let's do an example here. Let's say that we have a current going straight in this way. So this would be I1 going straight in that way. It then curves in an arc like that for 90 degrees. So that's a 90-degree arc right there. And the radius of curvature of that arc, we'll call that R1. And then it goes inwards, straight inwards, curves back here, raise the curvature R2. Okay, so it's another 90-degree arc, and then it goes straight outwards like that. Okay, and then we have a second current, I2, which goes straight in this way towards the center of all that, and then right here it stops and then goes around like that and then straight back out, and that is a 60-degree arc right there. Okay, and so this is going to be a radius R3. Okay, so let's say that I1 is 2.2 amps. Let's say that I2 is going to be 3.0 amps. All right, and let's say that R1 is going to be 1.2 centimeters. Let's say that R2 is going to be 0.75 centimeters. And let's say that R3 is 0.9 centimeters. And so I want to know what is the direction and magnitude of the magnetic field at the center. Okay, so think about that, and you say, okay, the magnetic field due to this and this and this and this. So the 4 and the 5 right here, the magnetic field of the 5 segments going radially are all 0. So all we have to do is find the magnetic field of this current, of that current, and of this current. Okay, so we'll call that B1, B2, and B3. So the total B is going to be B1 plus B2 plus B3. Okay. And so you look at that and say, well, that's pretty straightforward. Okay. Because it's 3 arcs right there. And we know that the magnetic field of an arc of charge, we just derived the magnetic field of an arc of charge. That is mu naught I times the angle divided by 4 pi r. Okay, so that's the magnetic field for an arc of charge. And so now all we need to do is figure this out for these 3 arcs right there. Okay, so B1, okay, that's going to be mu naught I1, okay, divided by 4 pi R1. Okay, now the angle is 90 degrees, so that is pi over 2. Okay, so that's going to be mu naught I over 8 R1. Okay, what about B2? Well, that's also 90 degrees. So that's going to be mu naught I1 over 8 R2. Okay. What about B3? Well, that's going to be mu naught I over 4 pi R3. Well, the angle is 60 degrees. So 60 degrees is pi over 3. So B3 is going to be mu naught I over 12 R3. Okay. So that's I2, sorry. All right, so that means the total magnetic field, okay, B1 plus B2 plus B3. So B1 was mu naught I over 8 R1. B2 was mu naught I over 8 R2. That was mu naught I over 12 R3. Well, we're not quite done yet because we need signs in here. Because this one, that one, here, we're doing this. So these are ones, 1, 2, sorry. Okay, so this one, right-hand rule, is going to be into the screen. So I can make that negative. Okay, this one right here is also into the screen. So that's also negative. This one right here going around that way, then by the right-hand rule is out. So I can make that one positive like that. So that would give me my total B right here. Okay. And so we look at that, and so we can say, well, we can clean this up a little bit. We would say that if we make that look a little bit neater, you know, this is going to be equal to mu naught times I2 over 12 R3, okay, plus I1 over 8 R1 plus I1 or minus I1 over 8 R1 minus I1 over 8 R2, and that's going to equal 0. Okay, so mu naught there is 4 pi times 10 to the minus 7. Okay, and so we have this, so we just plug in the numbers at this point. So we plug in all our numbers, and what we find is the magnetic field is going to be 4 pi times 10 to the minus 7 Tesla meter per amp times the I2, 3 amps, divided by the 0.9 centimeters is 9 times 10 to the minus 3 meters, minus the 2.2 amps divided by the 1.2 centimeters is 0.012 meters, minus 2.2 amps divided by the 0.9 centimeters is 9 times 10 to the, 0.75 centimeters. So 7.5 times 10 to the minus 3 meters. And so the magnetic field comes out to be a total of a negative 3.99 times 10 to the minus 5th Tesla. So that means it would be into the screen. Okay, so there we have an example here. And so that's all there is to that.